Okay, so we can start the session. Okay, so in the last class, okay, in the last sessions, maybe you studied the biology. Okay, today we are going through the chemistry part. Okay, so let's start. Okay, so today we are going to look on only two chapters, acid, base, and salt, and the chemical reactions and equations. So first of all, let me introduce myself. My name is Shamir, and welcome to Tara Global Academy. So in grade 10 chemistry, we have to deal with four chapters. One is chemical reactions and equations, acid, base, and salt, and metals and nonmetals, carbon and its compounds. So in so we are going to deal with chemical reactions and equations. Okay. So what is new with chemical reactions and equations? Basically, if you are focusing on CBSE board exam, basically they will simply ask the types of reaction as well the balancing of the reaction from this chapter. So two things are highly important. So the thing is types of reaction and the balancing of reaction. Okay. And in the types of reaction, we can simply say four types of reaction we are studying. One is combination reaction, decomposition reaction, displacement, double displacement, and one more. Okay, five type. Okay, and the oxidation reduction. Okay, so the combination, decomposition, the definition. You should study the basic things, including the definition, identification of a reaction. Suppose they have given some reaction, you should identify whether the reaction is combination, decomposition, displacement, and double displacement. Okay, normally, for example, for displacement reaction, we will, okay, for displacement reaction, they will give like this kind of compound like Na2SO4 plus BaCl2. Your product will be BaSO4 plus NaCl. This reaction is very common in double displacement reaction. Okay. Now, the other reaction we studied in our first chapter is nothing. Lead nitrate plus potassium iodide, simply a double displacement reaction. And double displacement reaction can cause a precipitation also. So yellow colored lead iodide is also the part of double displacement. Oh, sorry, not here. PbI2. Okay, 2Ki. Okay, these two are regularly asking in double displacement reaction. And the types of reaction, including the displacement reaction. Simply a displacement reaction will happen only when a highly reactive metal displaces less reactive metal from its salt solution. Okay, so that one is also important in types of reaction, and simply oxidation, reduction, addition of oxygen is oxidation, right? And the addition of hydrogen is reduction, that type. Okay, we will do the questions. We will do the questions at that time. We will get more idea. And the balancing of the reaction. Normally, which balancing is exactly important? If you check the previous year question papers, they are taking the question. Okay, regularly they will take the questions including, okay, including the aluminium. Considering aluminium plus oxygen, you will get Al2O3. Okay, normally you can see in many question paper you can see this the same one, and the aluminium plus HCl. Okay, that one, AlCl3 plus H2. This one is highly important. And you can see the balancing of aluminium oxide. Okay, Al2O3 plus HCl, or they can use Al2O3 plus NaOH. Actually, this equation we are studying from. Okay, we are studying from the third chapter, right? But still, this equation balancing will come for first chapter. Okay, so when you react aluminium oxide with hydrochloric acid, you will get AlCl3. plus H2O. Because you know Al2O3 aluminum oxide is an amphoteric oxide. What is amphoteric oxide? It shows the behavior of acid as well base. That means it can react with acid as well as base. Okay, so Al2O3 plus NaOH, you will get NaAlO2 plus H2O. Okay, now we can balance the reaction. You know, 2AlCl3 because 6HCl, 3H2O. Okay, so it's correct. Yes, oxygen 3 oxygen. So here also you can check 2 plus 1, 3. So you can write 2 here. Okay, so here 3 oxygen, 1 oxygen. Okay, uh, yeah, 2 here. So you will get 4 oxygen. Okay, now it is 4. Okay, now it is 4. Then hydrogen should be 2, 4. Actually, it's not. Okay. So two aluminum and oh, okay, two aluminum is there. Two NaAlO2, two H2O. Now it's fine, I think. You're right. Yes, oxygen 4 plus 1, 5, 3 plus 2, 5. So this is very important. These two equations are highly important. Regularly, they will ask for this kind of balancing. And one more thing, one more question we can reveal here, like Al2O3 is an amphoteric oxide. Explain using chemical equation. They can ask that kind of question also. Okay. Is it clear about the balancing of these two equations? Is it clear? Please unmute and respond. Hello, is it clear? Okay, I hope it's clear. Okay. Okay, yes. Then we can move to the next. Okay. Then what is important in first chapter? In first chapter, you can see some kind of MCQs are highly important. For example, silver. Silver, the color of silver is kind of gray color, right? So silver becomes okay, black appearance. Okay, silver have a black colored appearance. Why silver have a black, I mean, after some time, okay, if you are keeping silver outside, the silver got some black colored appearance. Why? Most of the people, I can say most of the people will write Ag2O. That is actually incorrect. Okay, not silver oxide. Silver will react with the hydrogen sulfide gas present in air and there occurs the formation of silver sulfide plus H2. This happened in case of black appearance. So this is black in color. Okay, so this is actually black in color. So you can see. So here the silver sulfide has black color. So silver become, so they can ask the gray colored silver becomes some black colored after some time. Which compound is formed there? So that is black color. And one more question in the same, okay, in textbook you can see in the same page, one more information. That means rusting of iron, you know. Rusting of iron is easy. That occurs the formation of Fe2O3, that's fine. But you know, the corrosion of copper. Copper is a metal, and you know, after some time, okay, after maybe months or years, after a year, what happened is that there occurs some corrosion for copper due to the basic copper carbonate. CuCO3 twice. Okay, this is the thing. So its color is we can see that its color is green. Basic copper carbonates. Okay, so you please note down this kind of MCQs are exactly important. Okay, is it clear? Please unmute and say whether it is clear or not. Okay, let it be interactive. Okay.
So,
Yes, sir.
Okay. Okay.
can you show the equation for this for copper
Calcium
carbonate?
copper carbonate formation, right?
Yes, sir.
Okay. So copper will react with carbon dioxide and water in air. Okay. Then you can say there occurs a formation of copper carbonate. Okay. Plus H2. Okay. So copper carbonate plus H2. Then you can balance like one copper, two CO3, 4 and 5, 6. Let it be 2, 2. Now it is fine. 2 carbon, 6 oxygen. Okay, so this is the formation of copper carbonate. Okay, it mostly happened due to the basic condition. Basic. So this is the reason we are rubbing kind of acidic substances like we can say the acidic substances. One question is there, I think in some pre-board exam. I think in IAS pre-board 1, I think. Anyway, the question is we are applying lemon juice in the tarnished copper. So if the copper carbonate is present, we will say that is okay. That is actually tarnished copper. Tarnished copper. That is the common name. Like rusting, not rusting. This is tarnished copper. For iron, we say the term rusting. For here, we will see the term tarnished copper. Clear? Okay. Then we can move to the next topic. So let's do, okay, these are the important MCQs. All of the important MCQs we did in our class and all. Okay, and we are moving to the important questions which can be asked from first chapter. Okay, so the first question. Yeah, first question. So the same question as I told you, when Ag is exposed to air, it gets black coating of, the answer is silver sulfide. Actually, not silver oxide. Always note that this is a common mistake. Okay, we may have some kind of a common mistake like this. Okay, so there is a chance of a common mistake like Ag2O because oxygen is excess in the air, right? But silver react more with carbon dioxide. Sorry, sulfur in air. Actually, the reaction between silver and oxygen is very less kind of inert one, but using sulfur it is there. Okay. Now next question. Which of the following is an endothermic process? Dilution of sulfuric acid, sublimation of dry ice, condensation of water vapors, respiration in human beings. Which will be the answer? Anyone? Which will be the answer here? Which is the endothermic process? Anyone? Anyone can say which is the endothermic process? Which is endothermic? Here, dilution of sulfuric acid, pakka exothermic. Right. Dilution of an acid is exothermic. At any cost, it's exothermic. Sublimation of dry ice. What do you mean by sublimation? Sublimation is the conversion of a solid substance directly to gas. Right. So sublimation means actually, directly we are giving some kind of energy and give rise to the gas. So always think if you are converting solid to liquid, that is actually endothermic. And liquid to gas actually endothermic because you are giving, okay, that's not D, right? So it is not like respiration in human beings is also exothermic. Okay, due to respiration, energy is produced, energy is released. Okay, and condensation of water vapor. Always think the conversion of a solid substance to liquid, you need energy. So we are providing energy, that is endothermic. Liquid to gas, endothermic. Same, solid to gas, endothermic. So we can say that are endothermic reactions. All are endothermic. What is the only exothermic? Condensation of water vapor means liquid. Okay, condensation of water vapor is gas to liquid. Okay, gas to liquid is an exothermic reaction. This is exothermic. Which is the answer? B is the answer. Sublimation of dry ice is an endothermic reaction. Because dry ice is the solid carbon dioxide. It will absorb the energy and it will convert to gas. Sublimation is the conversion of solid to gas directly. So you studied this the same term in 9. Okay. If you don't know, just note that sublimation is the conversion of a solid substance directly to gas. Okay, next. Magnesium ribbon is rubbed before burning because it has a coating of basic magnesium carbonate, basic magnesium oxide, basic magnesium sulfide, basic magnesium chloride. Which is the answer? Anyone? Here actually, please respond. Yeah. No. Yeah. Which one? Magnesium carbonate? No. It's actually magnesium oxide. Okay. The coating needs to remove the magnesium oxide. Okay, it's basic. You know, metallic oxides are basic. Okay, next. Next one. Give the ratio in which hydrogen and oxygen are present in water by volume. Hydrogen and oxygen. You know, in water, it's H2O. So what is the ratio? It's very easy. Okay, water by volume, 2:1. Yes, 2:1. Then, if they are asking by mass, okay, water by mass means 2 hydrogen, 2 and oxygen is 16, 1:8. So, they are asking by volume. So, if they are asking by mass, we should consider the atomic mass. Okay, I will send you this PDF, I mean, slides after the class. Okay, I hope it's clear. Okay, is it clear? Please respond. Okay. If you have any question, you can also, if you have any issues regarding the mic, you can also ask this question in the Q&A session. Okay, you can anywhere write it down. Next. State whether the given chemical reaction is a redox reaction or not. Actually, this reaction is highly important. This reaction is actually a redox reaction. Okay, consider MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Very important. Okay, here what happened? MnO2 become MnCl2. HCl become Cl2. That means removal of oxygen is reduction. Correct? And removal of hydrogen is oxidation. And the thing is, it's very important to study finding out the oxidizing agent and reducing agent. Most confusing, but very easy one. Oxidizing agent and reducing agent. What do you mean by oxidizing agent? Oxidizing agent is the chemical, is the substance which helped for oxidation. So this is the oxidation happens for HCl. Who helped for oxidation? MnO2 helped for oxidation. So MnO2 is the oxidizing agent. What do you mean by reducing agent? Reducing agent is the substance who who helped for reduction. Reduction happened for MnO2. So HCl helped for the reduction. Okay, this is a very important question. Next. A metal nitrate A on heating gives a metal oxide along with evolution of a brown colored gas B and a colorless gas, okay, which helps burning. An aqueous solution A when treated with potassium iodide forms a yellow precipitate. Identify A and B. Can you answer this question? Very easy. Nurul Haq, have you tried to answer this?
Yes, sir.
Yeah. So which is the answer? What is A
One
here? Come again.
I think it's silver bromide. Silver, right? Yeah.
Which nitrate?
Silver nitrate.
No, no, not silver nitrate.
No, no. Potash. Phosphorus, potassium, compound. Ah, it's that some bromide. I forgot that.
No, 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 no. This is actually lead nitrate.
Okay.
Okay. When you heat lead nitrate, you will get lead oxide, nitrogen dioxide, and the which is the gas help for burning. That is actually oxygen. Okay. So you will get 2, 2, 4. Okay, 4 plus 2, 6 oxygen. Okay. So this equation is highly important. Lead oxide is a yellow solid, not a precipitate, but simply solid. NO2 is the brown fume gas. Okay, brown gas, brown fumes. And this aqueous solution of A, so this one, aqueous solution of this one, PbNO3 twice again, react with potassium iodide, you will get PbI2 plus KNO3. This is yellow precipitate. Yellow precipitate. Name the both the reactions involved. Which is the type? This is, decomposition reaction. We can specify it as thermal decomposition. This one is double displacement reaction. Clear? Let's unmute and say that is clear. Or if you have any doubts, you can ask. Clear, right? Okay. Now let's have the next question. A student added few pieces of aluminium metal to two test tube. Okay, two test tube containing A and B. Okay, test tube A and B containing aqueous solution of iron sulfate, FeSO4, and CuSO. Aluminium metal to here. In the second part of her experiment, she added iron metal to another test tube C and D containing aqueous solution of aluminium sulfate and copper sulfate. So this is second part C and D containing aqueous solution of aluminium sulfate AL2SO4 thrice and copper sulfate. In which test tube or test tubes will she observe color change? Okay, here okay, here she added iron metal. So here added iron metal. So this is simply displacement reaction, right? Aluminum is more reactive than iron. So there is no reaction. So okay. So okay. Biology. Okay. So aluminium. Is more reactive than iron. So there is no reaction in C. What about in D? DFE plus CuSO4, you can see a color change because Fe plus CuSO4 gives FeSO4 plus Cu because Fe is more reactive. So here, here you can see a color change. Aluminium plus FeSO4 will give you Al2SO4 thrice plus Fe. Okay, Next, aluminium plus copper sulfate. That reaction always undergo because you know aluminum is more reactive than copper. Al2SO4, please balance it, okay? Like 3 Fe, 2, 2, 3. Okay, so this reaction can undergo. And also one more thing, students, you should study some color of some salt. For example, the aqueous solution of copper sulfate is blue. The aqueous solution of FeSO4 is pale green. Okay, pale green. Okay, that is also important. And you know, zinc sulfate is colorless. Even aluminum sulfate is also colorless. Okay. Is it clear? The reaction, displacement reaction? Can you please respond?
Yes, sir.
Yes, sir.
Okay. Then we can move to the next question first. 1 gram silver chloride is taken in China dish and China dish is placed in sunlight. Okay. Photolytic decomposition. Decomposition happens in presence of sunlight. So silver chloride. Okay. What will be your observation? So that color change you should study. Silver chloride is white, like a milky white. Okay, that is pure white precipitate. Okay, white colored solid. Silver is gray. Don't interchange the color. Okay, write the chemical reaction involved and you should balance it to AgCl to Ag. This is a regular question. Okay, in decomposition reaction, photolytic decomposition is exactly important. And you know this AgCl and AgBr, which is used in black and white photography. Okay, in some question they can ask a substance A in presence of light convert its white color to gray. This is used in photo black and white photography. That type of questions they can ask. Okay, identify the substance A. Okay, so that kind of questions they can ask. Okay, so don't miss that. Next. 1 gram of copper powder was taken in a China dish and heated. What changes will take place? What will be the change? Anyone can say copper is heated in China dish. What will be the change? You know, heated means that is oxidation reaction. Correct? So copper will react with oxygen to form copper oxide. You know, copper is brown in color, but copper oxide is black in color. That is the difference. Clear. So these are regular questions. Okay. So the final question from this chapter. To balance the following reaction chemical equation, the values of x, y should be respectively r. Okay, we did the reaction at the first, at the starting of the class. So NaOH react with Al2O3 forming NaAlO2 plus H2O. You know there is 2 aluminum. Definitely we need 2 aluminum, 2 Na, 2 NaOH. Okay, so you know what is the answer? 2 Na, 2 Na, 2 aluminum, 2 aluminum, oxygen 4 plus 1, 5, 3 plus 2, 5. So you know here X, Al2O3, only 1 Al2O3 we have taken and 2 NaAlO2. X and Y are 1 and 2 respectively. Now you okay, after the class just go through the whole chapter. Okay, we have discussed the important kind of questions in this chapter. Okay, so this is about the first chapter and always go through the decomposition of FeSO4 and FeSO4 with 2H2O, you know, green in color. Once you start heating, what happens? Color will disappear, become colorless. Correct? And when you continue the heating of FeSO4, it will convert to Fe2O3. Yeah, Fe2O3 plus SO2 and SO3. These reactions are also important. Just go through the reactions, go through all the reactions and types and take the time. Okay, now we can move to the next chapter, that is acids, bases, and salt. So give more importance to acids, bases, and salt. Okay, let's solve the questions from acid, bases, and salt. Okay. So the first question, oxides of aluminium and zinc are. Okay. What is the answer? Anyone? Oxides of aluminium and zinc are. What is the answer? Is it acidic, basic, amphoteric, or neutral? Anyone?
Amphoteric.
Yeah. This is so you can expect this kind of a question. Oxides of aluminium and zinc are amphoteric. Okay, there is no doubt. Next, select the following compound which is not a base. Sodium hydroxide, calcium hydroxide, sodium sulfate, zinc oxide, which is not a base. You can see hydroxide is present, right? Hydroxide means OH, so both are bases, so this will not be your answer. And what about C? C is actually not a base, not an acid, it's a salt. It's a salt of sodium hydroxide and sulfuric acid. So sodium sulfate is the answer. Zinc oxide actually can act as acid as well as base. Okay. So C is the correct answer. Zinc oxide, you know, is an amphoteric oxide. It can act as acid plus base. Acid and base. Sodium calcium oxide react vigorously with water to form calcium hydroxide, accompanied by the liberation of heat. Okay. From the information given above, it may be concluded that this reaction is it exothermic or endothermic? You know, this is very important reaction regarding your first chapter, right? In your first chapter is very important. Calcium oxide plus water, you will get calcium hydroxide. Correct. No need of a balance, it's already balanced. So it's an exothermic reaction. And what is the pH of this solution? Anyone? What will be the pH of that particular solution? Is it greater than 7, more than 7, equal to 7? You know, OH is present. Correct. OH is present. Then it is Paka base. So for base, pH is greater than 7. Okay, pH is greater than 7. So its exothermic pH of the solution formed is greater than 7. Next. An aqueous solution of a salt turns blue litmus to red. The salt could be obtained by the reaction. You know, what is the change? Here you can see blue to red. Blue to red conversion is possible only if your salt is an acidic salt. How acidic salt is forming? You know, salt is forming by the reaction of acid and base. Acidic salt is forming when only strong acid react with weak base. Okay, so which is strong acid, HNO3 is strong, but here base is also already strong, so this is not your option. Correct? So you can see here, H2SO4 is strong acid. That's okay. KOH is strong. So this is not your option. Always think NaOH, KOH, and CaOH twice we are considering as strong base. Even MgOH twice also. Okay. All other bases, all other OH containing compounds are weak bases, like NH4OH is weak base. So this is not your option. Only D is your option, HCl and NH4OH. So you should study the strong bases. Only 3 or 4 strong bases are there. Then acid present in tomato. Which is the acid present in tomato? Anyone? Or else I will call the name.
Oxalic.
Shazia. Yeah, correct. Okay, correct. So the answer is oxalic acid. And that part is important. You should study. Better to read the textbook. pH in everyday life. In most of the board exam, you can see at least 1 or 2 questions from pH in everyday life. What is important in that part? You can see the tooth enamel. Actually, our buccal cavity is slightly acidic, 6.8 pH. Our mouth. Okay. So the enamel present in our mouth, I mean in the teeth, is calcium phosphate. Calcium phosphate means calcium hydroxide is strong base, phosphoric acid is a weak acid. So it is a basic salt, basic in nature. Okay, when the pH of our mouth is become down less than 5.5, our enamel start corroding. Okay, so that is the concept. Okay, so pH in everyday life is important, and also andesite or nitrite. These are due to acid like methanoic acid. Methanoic acid is also known as formic acid. They can confuse you by giving the common name. Methanoic acid is the IUPAC name. Formic acid is the common name. Okay. Next question. Salt play important role in our daily life. Sodium chloride, which is known as common salt, is used almost in every kitchen. Baking soda is also a salt used in faster cooking as well as in baking industry. Okay. The family of salt is classified on the basis of cations and anions present in it. Identify the acid and base present in sodium chloride. Sodium chloride. How to find out acid and base? Just listen. Okay. Take the first element, add OH to it. So you will get the base, NaOH. Take the second element, add H before that. So you will get the acid HCl. Okay, so this is the idea how to find out the acid and base. Okay, next, find out the cation and anion present in calcium sulfate. Calcium sulfate formula CaSO4. So it will be Ca2 plus and SO4 minus. Or it, suppose, listen, suppose you don't know the symbol of sulfate. Just write like this. Anyway, the first person will be the cation. So you can write calcium cation. SO2 minus you can write sulfate anion. Okay, this way also you can. And also, suppose you are not sure about a chemical equation, don't go for that chemical equation. Just write it in words. Okay. Sodium chloride and washing soda belong to the same family of salt. Justify this statement. Yes, sodium chloride is NaCl. Baking soda, sorry, washing soda is Na2CO3, 10H2O. What is common in this? Sodium is common. So they belong to sodium salt family. Okay, sodium salt family. Okay, next. So just write the formula and whether check any common ions are present, then just name that ion as the family. Next. 1 gram of sodium chloride taken in a clean, dry test tube and concentrated sulfuric acid was added. So sodium chloride plus H2SO4. This is there in your textbook, and you will not, most of the students will not give importance to this. It's actually important. So NaCl plus H2SO4, double displacement, Na2SO4 plus HCl. Okay, so this is the reaction. Suppose you are confused. Suppose you are confused with balancing. Okay, I will give you another thing. Suppose you are confused with either Na2SO4 or NaSO4, then just write like this. Suppose you know Na plus SO4, you are writing NaSO4. Suppose, and you know H and Cl, you know it's Cl, but two hydrogens are present. You should give a 2 here, so 2 here, so 2 in Na2. Okay, so this is the reaction. And then this will be tested using dry and wet litmus paper, which will show the result. Okay, this is, HCl is an acid, hydrochloric acid, wet is required. Okay, the wet litmus paper only will give you a result. Okay, so using dry litmus paper, you will not get any kind of color change. Okay, so wet litmus paper required because H plus ions should be present. Okay, should be present. That is the thing. Okay, this is also an important question. Next, we can discuss one more question, and I think let's wind up. The industrial process used for the manufacture of caustic soda involves electrolysis of an aqueous solution of compound X. In this process, two gases Y and Z are liberated. Y is liberated at cathode and Z is liberated at anode. On treatment with dry slaked lime forms a compound B named Y, Z, and B. Here, what do you mean by caustic soda? Always think NaOH, the common name of NaOH is caustic soda. So the preparation of NaOH is known as chloralkali process. Electrolysis of aqueous solution of compound X. So what is X? X will be NaCl. Correct. And two gases Y and Z are liberated. So Y and Z are chlorine and hydrogen. How to find out? Liberated. Why is liberated cathode? Cathode has negative charge. So chlorine has negative, hydrogen has positive charge actually. So which will attract it towards cathode? Hydrogen. So cathode liberated is hydrogen. Anode liberated is chlorine. For an easiness, you can think about air conditioner AC. Anode, chlorine, AC. Okay, so on treatment with dry slaked lime form compound B. So what is compound B? Cl2 treating with Cl2 treating with dry slaked lime. That means CaOH twice you will get CaOCl2 plus H2. That is known as bleaching powder, calcium oxychlorate. Is it clear? This kind of question you can expect, like X, Y, A, B, and find out X, Y, that kind of question. Is it clear? Please unmute and say.
Yes, sir.
Okay. Now I am winding up. We will continue with this chapter and all the metals and non-metals and carbon compounds in the next class. So if you have any kind of question you can ask, I will give you 2 more minutes. 2 more minutes to ask your questions. Sir, do you take biology? No. Okay, biology. Yesterday, if you can watch the video in YouTube. Yesterday, already Shamim sir taken few chapters of biology. You can watch it. Okay. I will not take biology. I am the chemistry faculty in Tara Global Academy. Okay. Anyway, any other questions, any kind of questions, I will give you 2 more minutes. If you have any questions, you can write the same question in the chat box, or you can unmute and ask. For the YouTube people, you can also you can ask the questions in the comment box, or else we can wind up and we can continue with the next day, continue with the other chapters on the next day. Yeah, after 6:45, okay, after this session, you have physics. Okay, physics classes there. Shabas are taking physics class. Okay. So the same link, don't leave. You can continue with your physics lectures. So I'm leaving. Thank you. Thank you very much. And if you have any question, you can also note it down in your notebook. Next day we can solve it. I hope you don't have any question. Okay. So thank you for hearing me. So the physics teacher will come soon.
Okay, sir.
Yeah.
Bye. Sir, are you supposed to wait in this meeting or we'll join?
What, Lodha?
Are you supposed to leave this meeting or will you join?
No, your voice is not clear. Yeah.
Sir, are you supposed to join to that meeting or wait in this meeting?
No,
and
same link. I mean, same meeting.
Okay, okay. Okay, sir.
Bye. Thank you.
Yeah, what's good, my guy?
Bro, this is getting live. This is going live on YouTube.
What?
This is going live on YouTube.
What?
Actually, if you don't believe me, go check.
Bro, say it properly, nigga. You don't have a good network.
It's going live on YouTube.
Oh, okay. So is he live now?
Yeah, actually, we're live. I can see, like, I'm talking and I can see my name on the video.
Shit.
Actually, you go to our.
Guys,
Hello.
please, Nurul Haq and the Think 778. Can you please mute for a while?
Yes, sir.
Okay. 1 minute. What is this? That's better. Okay, guys. So let's start. Yeah, let me share my screen. I hope you all can see my screen, right? Yes or no? Hello, guys. Can you see my screen? Yes or no?
Yes, sir.
Okay, so for there are new faces are here. My name is Shabas. I am the physics faculty in Target Global Academy for the for the people who don't know me. Okay. So today in physics, I mean for the grade 10 year physics, we have 4 chapters. So in 4 chapters in just an hour, it's a complicated task. So today we will discuss some questions, and many of the students are requested to take the chapter electricity. So if we have time in the next session, we will take electricity chapters, specifically the chapter electricity. And today, if we have time at the end of this section, we will discuss all the important concepts and we'll make a small formula chart for the chapter electricity. Okay, so let's start with the questions. Look at the first question. An object is placed in front of a convex mirror. Convex mirror. Its image is formed. The question, at a distance equal to the object distance in front of the mirror. At twice the distance of object from the mirror. Oh, sorry guys, this question is convex. Yeah, this is a convex mirror. Yeah, you can tell the answer. So at a distance equal to the object distance in front of the mirror. If the image is formed in front of the mirror, in case of convex mirror, no. In the convex mirrors are always producing images that will be virtual. Virtual means the image is formed behind the mirror. So first option is not correct. Look at the next option. At twice the distance of the object from the mirror, can we say that? At twice the object? Nope. Half the distance of the object in front of the mirror? No, behind the mirror, and its position varies according to the object's distance. So this is the correct answer. So the image will be formed behind the mirror. The image will not be forming in front of the mirror. You know that. That is for a concave mirror. For a concave mirror, you can see this shading is inside. This is the principal axis. And we can say this is the pole, focus, and the center. Right. So if I have an object here at the center, a ray parallel to principal axis.
Side, right?
Yes.
On the other side, right?
Yeah, image will be formed on the other side. So we can say here the
Focal
focus
length
will be
of
here.
focus center of curvature.
What?
No, should we mark it on both the sides or only on one side?
No, mark it on the right side only.
Okay.
Okay, so we can say a ray will be passing through this one, and similarly I can say if a ray is passing through the center, it will retrace the same path. Okay, so it is retracing the same path, so I can say this light ray will be coming here. So the image will be formed here or somewhere. So definitely we can say that the image will be always virtual in case of convex mirrors. Understood? So this is the idea for the first one. Now the next question. When light enters, 1 minute guys, yeah. When light enters the atmosphere, it strikes extremely fine particles, which deflects the rays of light in all directions. This is due to what is that? Atmosphere. The light is hitting on atmospheric particles and it is spreading into all directions. What is that phenomena? Reflection? Nope. Is it atmospheric refraction? No. Scattering, yes, we can say scattering of light. That is the answer, scattering of light. So in this case, we can discuss the phenomena as reflection. Reflection, you already know that what is reflection. That is, suppose this is a reflecting surface. Suppose this is a plane mirror, and suppose this is a normal. This is the normal drawn to the plane of that mirror. And a light ray is coming here. This is light ray. This is the incident ray, and this is the reflected ray. Okay, the angle between normal and incident ray, that is I. Angle between normal and reflected ray, this is angle of reflection. So this both these angles will be same. That is in case of reflection. For the refraction means when light is traveling from one medium to another medium. That is, if this is one medium 1 and this is medium 2, and this is the surface of the medium. This line is the surface of the medium. When light is traveling from one medium to another medium, okay, so this is the normal drawn to this one. Actually, the light ray must go like this, but there will be a bending. Okay, this bending is called a refraction. So here, the atmospheric refraction, you know the phenomena of atmospheric refraction, that is for Earth. Let me wipe this. Suppose this is Earth's surface, and we know for Earth there are many layers are there. Troposphere, stratosphere, mesosphere, thermosphere or ionosphere. Many layers are there. And suppose this is a star, or this is a star. This is a sun, and light ray is coming and hitting on one of this layer, and it is going to bend because its refracting index will be different. Again, the light is going to hit on the other one, and again other one, like that. So this refraction on different layers of Earth, that is called the atmospheric refraction. Okay, then the scattering is the process. When the light ray is coming, suppose this is a small dust particle, this light is absorbed by this light particle, and this light is spreading into all directions. That is scattering. And the dispersion means white light is spreading into the VIBGYOR. Okay, so in this case, the answer is scattering of light. The next one, the refractive indices of three media are given here. Refractive indices of three media are given here. So this is medium 1, medium 2, medium 3, and their refracting index is also given. So first question, a ray of light is traveling from A to B. Another light ray is traveling from B to C. So one light ray is traveling from A to B, another one is traveling from B to C. The question, in which of the two cases the refracted ray bent towards the normal? So here we have the concept, when light is traveling from a rarer medium to denser medium. When light is traveling from a rarer medium to denser medium. Okay, so this is the, let me draw the normal, and this is the light ray. So light ray is coming here. When light is traveling from a rarer medium to denser medium, the bending will be towards the normal. Actually, the light ray must go like this, but the bending is towards the normal. Okay, and opposite, if the light ray is traveling from a denser medium to rarer medium, that is, light ray is traveling from denser medium to rarer medium. In that case, the refraction will be away from the normal. It is away from the normal. This is the condition, you know that. And the parameter that is determining whether a medium is denser or rarer, that is the refractive index. So if the refractive index is more, which means that medium is optically denser. Understood? If the refractive index of a medium is more, which means that medium is optically denser. So in this case, we can see two transitions, right? Two transitions are there. So in the first case, light ray is traveling from A to B, that is from 1.6 to 1.8. That is, light is traveling from a rarer medium to denser medium. That means the bending will be, here in this case, bending will be towards the normal, right? Because it is traveling from rarer medium to denser medium. Look at the next case, the transition is from D to C. That means the light is traveling from 1.8 to 1.5, which means it is traveling from a denser medium to rarer medium. So the bending will be away from the normal. I hope you understood. Guys, understood the concept? Hello? Guys, understood? Hello, guys, understood? Okay, so here we can say this is towards the normal. So in this question, they are asking like which of these two cases the refracted ray bends towards the normal, bends towards the normal. So towards the normal means only from A to B. Okay, so this A to B, A to B, this is bending towards the normal. In which case does the speed of light increases in the second medium? Yeah. In which of the cases the speed of light is increases in the second medium? Give answers, give reason for that. So we know refractive index is given by C divided by the speed of light in that medium. Or we can say V is equal to, just rearrange the equation, C by N, right? From this equation, we can say that the speed of light is inversely proportional to the refractive index, which means as the refractive index increases, the speed of light is decreasing, right? That is the meaning. Understood? As the refractive index increases, the speed of light is decreasing. So here, when it is traveling from denser medium to rarer medium to denser medium, here the refractive index is increasing, right? And at that case, speed of light is decreasing. So in this transition, the speed of light is decreasing. Speed of light is decreasing. But here, when it is traveling from a denser medium to rarer medium, the refractive index is decreasing. If the refractive index is decreasing, means the speed of light will be increasing. So we can say here the speed of light is increasing. So in from B to, from this case, for this case from B to C, the speed of light is increasing because it is traveling from a denser medium to rarer medium. So in the rarer medium, its speed of light will be maximum, will be more. Understood? A simple concept. Clear, guys? Hello, is it clear?
Yes, sir.
Yes, sir.
Okay. Yeah. The next question. Given figure shows three resistors, as you can see here. Find the combined resistance. This is a simple question. This is a simple question. So here we can say this R1 and R2 both are in parallel, right? But this system is in series with this one. Okay, so first I am going to find the effective resistance of these two. That is, if I find the effective resistance of that one, 1 by R equal to, since they are parallel, I have to use this equation. 1 by R1 plus 1 by R2. That is equal to 1 by 6 plus 1 by 2. So if you cross multiply or if you take LCM, in both way you can do that. I'm just cross multiplying this one. So it will be 2 plus 6 divided by 12. That is equal to 8 by 12. This is 1 by R. Then R will be equal to 12 upon 8. That will be equal to 12 upon 8. That will be equal to 3 by 2. That is equal to 1.5 ohm. 1.5 ohm. That means this system I can replace by this circuit. I can replace like this. That is, now this is only 1.5 ohm. This is just the 6 ohm. Okay, now we can say both these are in series. Therefore, the total resistance will be equal to R1 plus R2. This R1 plus R2. Okay, this is R1 now and this is R2. So we can say 1.5 plus 6, that is equal to 7.5 ohm. Understood? This is a simple question. This is a simple question. Understood, guys? Hello, guys. Understood? It's a simple question. Now, yeah. So in the in this case, for the series and parallel connections, 1 minute. We know for for parallel connection, we can say that the voltage will be same in each v. That means in this, the voltage across this resistance and voltage across this resistance will be same because both are in parallel. Understood? But if I measure voltage across this one, this won't be equal to this voltage. Okay, make sure, just understand that we'll discuss many circuit related problems in the upcoming questions. Okay, then going to the next question. For a current carrying solenoid as shown below, draw magnetic field lines and give reason to explain that out of the 3 points A, B, and C, at which of the points the strength of the magnetic field is maximum. Strength is maximum, and at which one it is minimum. So first, let's draw the magnetic field lines around this solenoid. Okay, so this is a solenoid. This is a solenoid. Yeah, and here current is entering through this one. Current is entering through this one, and current is leaving through this one. So just understand that the portion, the point where the current is entering to a solenoid, this side will be a south pole, and this side will be a north pole. Just understand that the side where the current is entering into the solenoid, that side will be south pole. Just keep in mind. And you know the magnetic field lines, that is very easy in case of solenoid. That is, the magnetic field lines around a solenoid is equal to the magnetic field lines around a bar magnet. You know how to draw the magnetic field lines around a bar magnet, right? Around a bar magnet, this is north pole, south pole. Then you just study this one. Yeah, the arrow is like this. Right, so north to south. You know how to draw this one, right? This is exactly similar here. So I'm just drawing that. Okay, so here this is the north pole, this is the south pole. So first let's start from here. Yeah, one, then again next one. Yeah, I'm just drawing two. Okay, then a straight line in the middle, then again like this, yeah. Okay, now let's draw the directions. So here the direction will be from north to south. You know the magnetic field lines are originating from the north pole and they are terminating at the south pole. So the direction will be like this. Understood? But inside, if they are forming a closed loop, inside it will be like this. Inside it will be opposite. You know that in case of a bar magnet, right? Okay, now the question is at which point we have three points C, A, B. We have 3 points A, B, C. At which point the magnetic field strength is maximum? What do you think, guys? At which point the magnetic field strength will be maximum? What do you think? At the B, we can say at B. At the point B will be here. At the point B, the number of field lines are very less. So if the number of field lines are more, or if the field lines are denser, which means the magnetic field strength is maximum there. But at the point B, the number of field lines are very less. So we can say at the point B, it is minimum. So minimum at the point B, because the magnetic field lines are less denser. Magnetic field lines are less denser. But at which point the magnetic field strength will be maximum? Inside or outside? At the point A or at the point C? What do you think? Guys, come on. What do you think? At which point the magnetic field will be maximum? I mean, maximum at which point? A or C? Come on, guys, just unmute and tell me the answer.
Yes, sir.
Are you sure? A. Anyone?
Yes, sir.
Yes. At the point A, the magnetic field will be maximum because at the point A, number of field lines are more when compared to C. So we can say maximum at the point C because the number of magnetic field lines are more there. Understood? Very simple question. Now going to the next question. Yeah, Rohit wants an inverted image of an object using concave mirror. If he kept an object at 50 centimeter from the mirror, so the object distance is given and the image is formed at 30 centimeter from the mirror, then specify the range of focal length. We have to find the focal length. Okay, so first let's find the focal length. So here we have a concave mirror. So for concave mirror, U is negative because we are always placing an object in front of the mirror. So all the reading taken left to the left of the mirror is taken as negative. Then the image is formed 30 centimeter in front of the mirror. So again, we can say the image is formed here. So V is also negative. So U, I can say that is equal to negative 50 centimeter. And V is also negative 30 centimeter. Understood? Now just find the focal length. Let's find that. We know by the mirror formula, 1 by F is equal to 1 by V plus 1 by U. Substituting here, 1 by V is minus 30, then plus 1 by minus 50. That is equal to minus 50 plus minus 30 divided by minus 30 into minus 50. Okay, that means here you get, if you do this one, you get minus 50 minus 30, that is minus 80 divided by minus 30 into 50. So 3 into 5, so this minus and minus will be plus. So 3 into 5, that is 15 into 2 zeros will be there. So this is 1 by F. So F will be equal to 150 upon 8. 150 upon 8. Understood, guys? Understood? Hello, guys, understood? So this will be equal to around 18.75 centimeter. Hello, understood? Okay, clear. Now the next one, draw a ray diagram to show the image formation in this case. I mean, you don't have to draw with a 50 centimeter line or 30 centimeter. Just draw a rough diagram. So this is for question number A. For the question number B, let's draw a concave mirror first. Sorry, let's draw a concave mirror. And this is the principal axis. Yeah, principal axis, and this is the pole, this is the focus, then this distance must be equal to, yeah, this will be the center. Okay, this is a concave mirror, and here the focal length we got as 18. It will be negative 18. Okay, negative 18. So focal length is just only 18 minus 18, and the object is placed at the 50 centimeter, which means it is behind C. That means this is 18.75. So this will be equal to again 18.75. So total this distance will be equal to 37.5. But the object distance is 50. Understood? Clear, guys? Now let's draw it. Now let's draw the ray diagram. So a ray parallel to the principal axis passing through the focus. Yeah. passing through the focus, and a ray passing through the focus. So passing through the center, actually the mirror is here, okay, and retracing the same path. Okay, so here they are meeting, so we can say the image is formed here. This is the dry diagram for that. Okay, understood. Okay, so the image formed here, you see, it is the V is in between this 37.5 and this 18.5. So we can say, definitely this is correct. Okay, this is correct because V is minus 30, that is in between C and F. We got it correct. Clear. State the magnification produced by the mirror in this case. Magnification. It will be greater than 1 or less than 1. In this case, we can say the image will be diminished, right? The image will be diminished. So we can say magnification will be, definitely it will be less than 1. It will be less than 1. Or let's find the magnification also, no problem. We know C is equal, magnification for the mirrors, it is minus V by U. So V, it is minus 30. So negative of negative 30 divided by U is minus 50. This negative and negative is positive. So it will be equal to minus 3 by 5. Minus 3 by 5 will be, it will be always less than 1, right? So this is the magnification produced, and the negative meaning, negative indicates that the image is inverted. Clear? So this is also a simple question. Understood, guys? Understood? Clear? Hello all, is it clear?
Okay.
Okay. Now going to the next question. Going to the next question. State the law that explains the heating effect of electric current. Heating effect of electric current. Which is that law? Joule's law. So we can say Joule's law is that. Joule's law. So Joule's law states that the heat produced when current is passing through a conductor is directly proportional to square of the current, resistance, and time of flow. That means heat produced, in words we can say heat produced when current is passing through a conductor. When current is passing through a conductor. Passing through a conductor is directly proportional to, as you can see here, square of the current, resistance, and time of flow. Just add those words here. You got the answer. Okay. Then next one, list the factors on which resistance of a resistance of a conductor depends. That means you already know resistance is equal to rho L by A. All the dependent factors are here in this equation. So the first one is, let's take the length. Second one, area of cross section. Area of cross section. And the third one, rho, that is resistivity. Resistivity is the property of a material. So let's write it as nature of the material. Nature of the material. And one more term is there, that is temperature. That is temperature. So the dependence of temperature you will study in the higher grades. Okay, if you are choosing science. Okay, so the factors affecting resistance is, length, area of cross section, nature of the material, and temperature. Just write the equation rho L by A and just explain what is the terms. You got the answer. Okay, so that's one also is a simple question. The next one, the given image shows a thin lens of focal length 5 centimeter. Here the focal length is just 5 centimeter. You can see the figure here. So what is the kind of lens shown in the above figure? What kind of lens is this? We can say definitely this is a convex, no doubt, convex lens. If a real image is to be formed at a distance 7 centimeter from the optical center, means from this thing, from this optical center, then show with the calculation where should be the object to be placed. Okay, that means here in this question for the B, we can say the focal length is given here, that is 5 centimeter. Okay, and the image must be formed at 7 meter from the 7 meter from the optical. Actually, it is not 7 meter, it is 7 centimeter. Okay, so that is a mistake in the question. So V is 7 centimeter, not meter. Okay, 7 centimeter. We have to show with the calculation where should be the object is placed. Okay. Sorry, here also it is centimeter. Anyway, so in this question it is all in meter. So I'm taking all as meters. Okay, so it's also 5 meter and 7 meter. We have to find what is U. Where should we place the object? I'm using the lens formula 1 by f equal to 1 by v minus 1 by u. Or I can say 1 by u. I am taking 1 by u to this side. So it will be plus 1 by u. So 1 by u or 1 by f plus 1 by u equal to 1 by v. Taking 1 by f to that side. Or I can say 1 by u is equal to 1 by v minus 1 by f. Understood. So 1 by, what is v here? That is 7 minus 1 by focal length is 5. That means 5 minus 7 divided by 75 are 35. That is equal to minus 2 by 35. This is 1 by u, or u should be equal to 35 divided by 2, or negative sign is there. That means it is equal to 17.5 minus 17.5 meter. That means we have to place an object at 17.5 meter away from the lens. The negative sign indicates that the object should be on the left side of the lens. Understood, guys? Clear? Hello, understood? So in this case, it's a twisting question. That is, we have to calculate the object distance. So we just rearrange the lens formula for our need. So 1 by u will be equal to 1 by v minus 1 by f. Just directly substitute the values here. We got the answer. So u equal to minus 17.5 meter. Okay. Then here we have another one. Draw neatly a label diagram. So neatly, I don't think it will be neat. Anyway, let's try a diagram in the mentioned in the 2. Okay. That means here if we place an object, here, this is the lens. So this is the origin, and this is f1, this is 2f1, this is f2, and this is 2f2. In this case, the focal length is just 5 meter. So this is 5. So this will be again 5. So total this one is 5. But in this case, the object distance is given. We got it as 17.5. So it will be behind 2f1. The object will be behind 2f1. Now we can do this one. So a ray parallel to principal axis, after the refraction, it will pass through the focus. It is passing through the focus. Now a light ray is passing through the, we can say passing through the origin again. Origin, it will be going to the, yeah, like this. Okay, so image, we got the images here. We got the images formed here. So this is the ray diagram. Okay, so when you draw the ray diagram, these arrows are very important. Okay, these arrows are very important. Understood? Understood. So this one is also a simple question, but here, I mean, in the normal question, they will ask you to find the image position. Or normally the question will be to find what is the position of the image, or where the image is formed. But in this case, the image position is given, but you have to find the object distance. Okay. Okay. Hello, zeros and ones. Going to the next question. A 10 centimeter long pencil is placed 5 centimeter in front of a concave mirror of a radius of curvature 40 centimeter. So the question, we have to determine the position of the image, size of the image, draw the ray diagram. A simple question. In this case, we have a 10 centimeter long pencil, which means that is height of the object is given. Okay, so that is 10 centimeter, and it is placed 5 centimeter in front of a concave mirror. So u is given, that is negative 5 centimeter. That is, this is placed in front of the mirror. That is why the negative sign. And here the focal length is not given, but the radius of curvature is given. So radius of curvature is 40 centimeter means, 40 centimeter means, we know radius is equal to r equal to 2f. R equal to 2f, or f is equal to r by 2. So r is 40 means this is 40 by 2, that is equal to 20 centimeter. We got the focal length. Focal length is 20 centimeter. The question, determine the position of the image formed. Determine the position of the image formed. So where will be the image formed? So look at this case. This is the case here. That is, we have a concave mirror. We have a concave mirror, and whose focal length is, this is pole, focus, and center. Whose focal length is 20 centimeter, but the object is placed at 5 centimeter from it. So the object is placed 5 centimeter. That means the object is placed here. So this is a special case. You know this case, right? In this case, image formed will be on the left side. You know that image formed will be on the left side. Right, image will be formed on the left side. It will be a virtual image. Understood? So you know the position of the image. It will be on the in front of the mirror. The image will be formed in front of the mirror. And what is the size of the image? So let's find it mathematically. Therefore, we can say 1 by f is equal to 1 by v minus 1 by v plus 1 by u. So let's find 1 by v equal to 1 by f minus 1 by u. That is, I'm taking 1 by u to left side. Here the focal length is 20. It is not 20, it is negative 20. Understand? Because this is a concave mirror. So it will be negative. Minus 1 by u is 5, right? U is 5. So 1 by minus 5 is the substituting here. So here you get minus 20 minus 5 divided by, it will be 100. Minus 20 into 5 will be 100. So that is equal to minus 15 divided by 100 will be the, this is equal to 1 by v, or v is equal to 100 upon negative 15. Okay, you can just minimize this one, or this thing will be equal to 10 divided by 3. 10 by 3 will be the answer. That is equal to 333 point, yeah, 3.333. Sorry, it will be equal to 333 point, sorry, a small mistake, sorry guys. So it will be 20 by 3. If we do with 5, it will be 20 by 3. 20 by 3 will be equal to 6.6666, right? 20 by 3 will be equal to 6.66. Yeah, it will be equal to 6.666, or negative sign is there. So negative 6.666 centimeter. So the image will be formed in front of the mirror at 66.666 centimeters. Okay. And what is the size of the image? How we can find size of the image? The B part. So the B part I'm doing here. Yeah, we know magnification is given by HI by HO. That is, for the case of mirrors, it will be minus V by U. I'm taking only this part. So the height of the image will be equal to taking HO to right side. Minus V by U into HO. So minus V by U, minus V is 66.66. I'm just taking 20 by 3. Okay. So minus of minus 20 by 3. Minus of minus 20 by 3 divided by U is negative 5. Negative 5. This negative and negative is cancelled, and into HO is 10 centimeter. So it will be equal to 200 divided by 15 will be there again. So it will be equal to 200 divided by 16 will be there. So in this case, it will be enlarged image. So it will be equal to 200 divided by 15. That will be equal to, you get 13.333 centimeter. Okay, that means the image is enlarged. Understood? The image is enlarged. Okay, now the third question of this one, draw a ray diagram to show the image formation. You know the special case, right? You know the special case. You can just complete it. You know the ray diagram in this case, the special case. Okay. Moving to the next question, the 10th question. So this is the last question. Vinita and Ahmad demonstrated that operates two headlights and two side lights of a car in their school exhibition. Based on their demonstrated circuit, answer the following question. So as you can see here, this is a circuit. A 12-volt battery is there, and here we have two switches. Three switches are there. 1, 2, 3. 3 points are there. The question number 1. State what happens when switch A is connected to the position 2. That is, this thing is going to connect here. Then what will happen? The current will be flowing through this wing. Right. So what will happen if we connect to the position 2? We can say 12 ohm bulbs will glow. 12 ohm bulbs will glow. Bulbs will glow. Right. And if it is connected to the position 3, if the A is connected to the position 3, in that case only these 4 ohms will glow. Okay, only the 4 ohm bulbs will glow. Bulbs will glow. Okay, so if it is connected to the position 3, the 4 ohm bulbs will glow. If it is connected to the position 2, this 12 ohm will glow. But if it is connected to the 2 ohm, this will not glow. Okay, this 4 ohm will not glow if it is connected to the position 2. What if they are connected to the position A? What if they are connected to the position A? Nothing will glow, right? Nothing will glow. Next one. Find the potential difference across each lamp when lit. Find the potential difference across each lamp when lit. Okay, so first I am going to find for the 12 ohm. For 12 ohm. Listen guys, here we are using the property of, so first when it is connected to the position 2, I can say this is a 12 voltage current is coming here. And one more thing, these two are in parallel, right? These two are in parallel, right? Both of them are in parallel. So the specialty of parallel connection means the voltage through everything will be same. That means 12 volt will be flowing through this one. Again, 12 volt will be flowing through this one. Okay, so we can say that the voltage through this one will be, we have to find the potential difference. Okay, very good. So we don't have to calculate anything. So we can say 12 volt will be flowing through this one, 12 volt will be flowing through this one. Okay. Okay. So then if it is connected to here, then also 12 volt will be flowing through this one, 12 volt will be flowing through this one. Okay, so we can say the potential difference will be again 12 volt, and calculate the current through each wing. Calculate the current through each wing. So we can say that the current is given by I equal to V by R. We can say voltage is 12 divided by the resistance is 12. That is equal to 1 ampere through the 12 ohm. Okay, but in this case, for the other case, it will be V by R will be the voltage is again 12 volt. The resistance is 4 ohm. That is equal to 3 ampere. So 3 ampere current will be flowing through the 4 ohm bulb, but the 1 ampere current will be flowing through this bulb. Okay, so guys, now let's wind up here. We can continue this session also. I told you that there will be a session for the chapter electricity. We will discuss the same in the next class. Now let's wind up and we'll continue in the next class. So I hope you all understood. And if you do you have any doubt? Do you have any doubt, guys? Any doubt? Hello, guys. Any doubt?
Sir.
Yes.
Okay, sir. Bye.
Okay.
Hello.
So if you don't have any doubt, let's wind up and we will continue in the next class.
Okay, sir.
Okay. Okay then. Bye, guys.
Bye.
And all the best for your exam. Bye bye.